Good morning to all. Today we going to the topic in the course name transforms and partial differential equation. Second year third semester mechanical engineering students. Myself, I am K. Palanivel, AP, Assistant Professor in Mathematics, SNS College of Engineering, Coimbatore. Today we going to the topic in the case study Fourier series in demand forecasting in industry. In the fashion industry, the demand forecasting is particularly complex. Companies operate with a large variety of short life cycle products, deeply influenced by seasonal sales, promotional events, weather conditions, advertising and marketing campaigns on top festivities and socio-economic factors. At the same time, self out of stock phenomena must be avoided at all costs, given the strong seasonal nature of products that the characterized the fashion sector. This paper aims to highlight how the Fourier method can uh, represent an easy and more effective forecasting method compared to other widespread heuristics normally used. For this purpose, a comparison between the fast Fourier transform algorithm and another two techniques based on moving average and exponential smoothing was carried out on a set of Fourier historical sales data. Medium and large sized companies which operates in the women's textiles, apparel and clothing sectors. The entire analysis was performed a common sheet in order to demonstrate the accurate results, exploring advanced numerical computation techniques using expensive software. Introduction. The role of demand forecasting has become increasingly important within business that have a maximization, a customer service, and the optimization of capital investment operating cost as their main objective of this aim of the course. Demand forecasting is also considered to effective supply chain management and it plays a crucial role, especially in the long term, in identifying the direction of the business strategy. The forecast accuracy affects all levels of production systems from the generation of production plans to the calculation of material requirements and consequently to supply chain management. An accurate cost can lead to significant cost savings, reduced working capital in safety stocks, the strengthening of customers' relationship, and increasing competitiveness. However, it is well known that accurate forecasts are extremely difficult to attain due to many factors from macroeconomic changes and unpredictability of markets of fashion effects. The complexity of this problem may push companies to pursue specific software such as forecasting decision support systems. However, as these are extremely expensive, in most cases, companies choose to use simple statistical approaches such as implementing moving average or exponential smoothing heuristics. As consequence, this basis forecast need to reviewed in a order to take into account exceptional circumstances or events that may not emerge from historical data. As a result, up to 80% of forecast are adjusted through experimental evidence from someone author suggest that judgmental adjustments to statistical forecast are usually unnecessary. In the fashion industry, demand forecasting is particularly complex. companies in this specific sector operate with the large operate with the large variety of short life cycle products deeply influenced by seasonal sales, promotional events, weather conditions, and advertising and marketing campaigns, as well as festivities and economic and social factors. Moreover, these slow moving expensive products usually face an intermittent or lumpy demand, but at the same time, as they are usually high margin items, self out of stock phenomena must be avoided at the all cost. The quick and effective supply chains. Next one, forecasting approaches. Forecasting approaches can be divided into qualitative and quantitative methods. Here, we focus on quantitative methods based on the study of historical time series. Among these, the most well known are the moving average and the exponential smoothing methods, Holt Winters methods, and regressives. That's, however, in having to deal with lumpy demand, cross-turn methods, and it is evaluation as for. Next one is other methods that have been used in the fashion industry providing successful results in sales prediction include two-stage dynamic sales forecasting models, fuzzy logic approaches, artificial neural networks, and extreme learning machines. Despite their effectiveness, few commercial software solutions implement these methods for forecasting that few that too are often too expensive for small or medium-sized companies. As a result in practical as a result in as a result in practical cases, most companies use basic heuristic implemented to common sheets. Like, therefore, this approach has been used for forecasting changes, electricity demand, and prices, which are variable that are clearly related to light and temperature cyclic variations. In forecasting consumers behavior, it has been used for estimating the volumes of incoming calls in a call center and has been integrated with a linear equation for forecasting motorcycle sales with successful results, whilst it didn't lead to significant improvements for forecasting automobile sales. Apart from these few examples, FFT, fast Fourier transform. FFT means fast Fourier transform seems to be applied only rarely for forecasting consumer goods sales, and to the author's knowledge, no contribute seem to be present in the literature for forecasting consumer goods sales, specifically in the fashion industry. In the next session, present in the detail both the methodology and the step-by-step procedure used to apply fast Fourier transform on historical time series to predict sales. Next one, methodology. This one is presents both the methodology and the step-by-step procedure used to apply fast Fourier transform FFT to historical time series for forecast sales in detail. In this other section, results proving the effectiveness of the suggested approach are shown by analyzing a fashion company data. The whole analysis was performed on a common spreadsheet order to prove the accurate analysis exploiting advanced numerical computation techniques can be carried out without needing to use expensive software. Microsoft Excel software is able to compute fast Fourier transform FFT on a data vector. The FFT algorithm significantly reduces computational times compared to the standard Fourier transform. And specifically the Fourier series is used to Microsoft Excel not firmly convinced to perform such mathematical analysis. It is easy and quick to calculate the discrete Fourier transform DFT. Discrete Fourier transform DFT, the data range. Next, in this analysis, the FFT was used to perform spectral analysis on sales patterns in order to attain a frequency spectrum, the representation of which is often referred to as periodogram. This is because of the Fourier transform can decompose a periodic series into some sinusoidal functions. Except example harmonic components, specifically cosine functions. In Microsoft Excel, the FFT returns complex numbers from which it is possible to extract information frequency, amplitude, and space of capital N by 2 periodic waves that form the sales pattern, where N is the total number of time periods of sales data. This is important one. N is what? The N is the total number of time periods of sales data, which is also the size of the sample. Also, the size of the sample uh, sampling criterion is signal theory. This is the result is the Fourier transforms or Fourier series. Applying the Microsoft Excel Fourier analysis tool, Microsoft Excel in the Fourier analysis tool on a capital N sized data range, it yields an N sized range of complex numbers which contain information on N components. However, the previously stated only the first half should be considered. First half should be considered. The next one, the imaginary parts. The Excel provides simple functions that can be easily to calculate the amplitude and phase of each of the capital N by 2 significant component from each complex numbers. Next one, Next one, we see the examples of periodogram generated from different signals. Diagram is the first one. See this. The wavelength. First one is original signal. Next one is frequency spectrum. You see that diagram. Next one, procedure to attain an accurate forecast through Fourier analysis is applied as follows. Is 10 conditions as follows. First one is extract the historical series of data related to the item to be analyzed over a significant time interval. This is first one. Second one is divide the data into two subsets, a calibration data set and a validation data set, which allows the quality of the results to be analyzed. The calibration set should be composed of n values. N needs to be power of 2. Third one is calculate a linear trend of the series of the calibration set and subtract it from the data series. Next one, calculate the fast Fourier transform FFT on the degenerate data. Next one, create the frequency spectrum by calculating for each of the first capital N by 2 components their amplitude and space. Next one is except for f naught, the starting one f naught, order the f1 to etc f suffix capital N by 2 components in a decreasing order to amplitude. Perform the inverse Fourier transform capital N by 2 times or sum the wave components taking into account each of the n by 2 components progressively starting from f naught up to the n by 2th. Reapply the eliminated trend. Reapply the eliminated trend calculated instead third one to each of the n by 2 inverse Fourier series or transform. Compare the validation data with each of the n by 2 inverse Fourier transform calculating the forecast error with the preferred method. Forecasting error with the preferred method. Example, mean absolute percentage error. Mean absolute percentage error. MAP. MAPE. Is important one. This one is never mind. Mean absolute percentage error. MAP. MAPE. Next one, last one. Choose the most appropriate number of wave components to consider in order to minimize the error. Next one is application to fashion products. To calculate the sale forecast for a medium to large sized fashion companies operating in the women's textiles, apparel, and clothing sectors. Several product categories were analyzed, and as the results, the application of the proposed method generally yielded more accurate forecasts in comparison with two of the most commonly used approaches based on moving, average, and exponential smoothing. Two examples are presented here. The trolley subcategory and the belt subcategory, the Fourier analysis applied to the historical series of the former returned a much more precise forecast, while with a latter the forecasting error was comparable with that obtained with the other two approaches datasets and the validation dataset, calibration dataset, and validation dataset. With the moving average and exponential smoothing techniques and traditional approaches were used to calculate weekly ratios using three periods of historical data. The parameter in the exponential smoothing was chosen different way in each case. About of this. Next one, the trolley subcategory. Calibration data. The calibration data set of trolley subcategory sales is shown in the below diagram. See this below diagram. The calibration data set subcategory sales. Next one, forecasting results comparison in the diagram. Forecasting result. First calibration diagram. Next one is forecasting diagram. Next, the belt subcategory. Next one, see this diagram, the belt subcategory. The belt subcategory, the calibration data set of the belt subcategory sales in shown in the following figure. Next one is comparison of the forecasting results. See this comparison of the forecasting results. This recent high peak significantly influenced the moving average and exponential smoothing techniques, and both methods forecasted a higher sales volume compared to what really occurred. On the contrary, in both cases, the Fourier analysis yielded much more activities. In both cases, Fourier analysis yielded much more accurate results in the flow diagram. Forecasting result comparison and Fourier is a yellow color is marked the Fourier, and the dot is used to move the average, and another one dot is the exponential smoothing. See this diagram, exponential smoothing also. Next one, we are going to conclusion. Okay, the accurate forecasts are extremely difficult to attain. As a result, large sized companies may be pushed to purchase the expensive forecasting software, whilst small and medium sized enterprises generally choose to use simple statistical approaches on common sheets. However, common sheets do not support only basic techniques. For instance, the fast Fourier transform is FFT. The fast Fourier transform, which has been widely used and applied in many fields ranging from physics, seismology, engineering, and economics, allows certain limitations present in other techniques in capturing seasonality phenomena to be overcome. Therefore, thanks to its capability in terms of decomposing a function into sum of sinusoids of different frequencies, amplitude, and phase, Fourier analysis has been used to forecasting changes in electricity demand and or and prices. However, it seems to be only rarely applied in consumer goods sales forecasting, and no contributions seem to be present in the literature for forecasting consumer goods sales. Specifically, in the fashion industry, in this paper, a comparison in this paper is comparison between the FFT analysis in Microsoft Excel and another techniques based on moving average and exponential smoothing methods was carried out on a set of the historical data using is the fashion company operating in the women's textiles apparel and clothing sectors, and which distributes over more products to more than one shops. The results show how Fourier analysis represents a valid alternative forecasting technique among those that can be easily implemented on a common sheets. Clearly, its effectiveness varies with the sales pattern characteristics for certain sets of historical data. The suggested approach can attain much more accurate results compared to other simple heuristics such as moving average of exponential smoothing methods. In other patterns, the accuracy can be comparable. In this results, the above results, the weekly sales of two product categories were analyzed. For fourth categories, Fourier series yielded two smaller error but both in terms compared to the two classical techniques. However, for one category which displayed quite an irregular historical pattern, Fourier analysis reduced to our Fourier series reduced to error by 30% on average between the two indexes. On the contrary, for the second category, which displayed a more regular historical pattern, the average error reduction was 22%. MAP is 30% and MAD is 22%. A 10-step simple and straightforward procedure is described above. We see the above list. Next one, no complex data procedure is required clearly. Further improvements can originate from the application of these techniques that were conceived of in signal theory to refine the Fourier transform through an appropriate signal windowing procedure. However, the study's approach was intentionally described in its simplest form in order to provide a solid foundation both the research both the research foundation for research particulars. Okay, we see the above categories, all of these totally. This is a case study of Fourier series for demand forecasting in industry. Total introduction. You see that and the forecasting approaches, how to use the methodology and solving the industry forecasting case studies, starting the diagrams in the F naught, starting the F naught, the other components in the spectrum were sorted by decreasing amplitude according to the on the step in the mentioned procedure. The results are shown in these figures. The below these trolleys of category in these figures we see that, and also the results, the calibration dataset results are confirmed the numerical comparison in the table the MAD and MAP. The Fourier analysis found to yield much smaller error both times in this data calibration set of areas. Okay, thank you for watching. Thank you guys.